Welcome. A little bit more about probability. We've learned about independent events and dependent events, and today we're going to find some probabilities without using a probability tree. Let's look at this first one. There's a dartboard, and let's say my chances of hitting the bullseye are 0.1. So the probability of a hit are 1 out of 10, 0.1. Yep. Automatically then, the chances of me missing are the other 9 out of 10, right? Probability of a miss, so hit and miss. Probability of a miss are then 0.9. Not out of 10, 1 out of 10. They add up to 10 out of 10 equals 1. Okay. These are the chances of hitting and missing. Now, what if I'm attempting to hit the bullseye? What are the chances of me attempting and only getting the first hit on my 4th attempt? So that means I would have to, so what are we finding the probability of? We're finding the probability of first missing, then second attempt missing again, third attempt also missing, and then the 4th attempt getting a hit, right? That's what we're finding the probability for, because we're asking ourselves, what are the chances that I get my first bullseye on my 4th attempt? Okay, there's only one way to get this. The hit has to be the 4th one, and the first 3 have to be a miss. Okay. Let's structure this a little bit. Probability of getting miss, hit are equal to the probability of missing times the probability of missing times then the probability of missing times the probability of then getting hit. These events, these 4 attempts, are independent, right? Think about that for a minute. Whether I miss the first one or not, on my second attempt, my chances are still the same, right? The dartboard's no different. Let's assume I'm not getting super disappointed and discouraged and are not able to throw the arrow anymore. These 4 events are independent. My chance of getting bullseye is 1 out of 10 each time. Yeah? That's why these 3 misses have the same probability. So we find the probability of getting miss, hit by multiplying these separate probabilities, which the probability of getting a miss is 0.9, and I'm multiplying that by 0.9 again on my second attempt, multiplied by 0.9 again on my third attempt, then multiplied by 0.1, which is the chance that I get bullseye right there. And if I do that calculation, I could grab my calculator for that. I get this. So the probability of getting miss, hit is a little more than 7%, right? Now I did this without drawing a whole probability tree, and that's because I had a little bit of fun. I tried to draw and I succeeded. I made a beautiful probability tree, and it's nice, and it's all correct, and I could go and find all these separate probabilities, but it's a lot of work, right? So once I've drawn many of these, I can probably sort of see this when I close my eyes while I'm thinking about this question. I was imagining my way through the tree where I get first a miss, then a miss, then a miss, then a hit, right? Miss, 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 hit. This one. Because there's only 1 out of 16, is it 16? Yes. 16 outcomes, only one of them I'm interested in. So I'm not going to draw all of this out because I know what it would look like, right? But just to help you visualize, this is where my calculation would have been in my probability tree, right? Okay, let's do another one with a bag of marbles. Oops, my marbles went flying. There's a blue one. Ah, come here. Another blue one. Do I have a total of 8 now? 1, 2, 3, 4, 5, 6, 7, 8. There's 8 marbles. Okay. A bag of marbles. There's 5 blue ones, 3 red ones. I'm going to pick a marble at random without looking, look at the color, and leave it outside of the bag. Yeah? And I do that, oh, blue again. I do that until I get a red one. Oh, red, I'm done. Yeah? That's a fun game. I'm going to pick out marbles until I get a red one. The marbles are not replaced. Now find the probability that I will get my first red one on the third selection. That was actually the example I just showed. So a blue one, then a blue one, then a red one. What are the chances that I get the first red one on my third attempt? Let's think about what that would look like. There's actually only one way for that to happen, right? Getting the first red one on the third draw. That would be a blue one, then a blue one, then a red one. Got my first red one on the third attempt. So what is the probability of getting blue, blue, and then red? Okay. This time it's a little bit more complicated than the last one because the events are dependent. The chances of getting a blue on the first draw is different from the chances of getting a blue on the second draw. Just call it B2, blue on the third selection. The chances of getting blue, blue, red. So the chances of getting red on my third draw, that one's going to be there. So I'm multiplying the probability of getting blue on the first draw by the probability of getting blue on the second draw by the probability of getting red on the third draw, given that 2 blue ones are already out here, and here, given that 1 blue one is already out when we draw this one. Okay. Ooh, it's a little more complicated, right? Cool. Let's just pull them out as we go along, right? What is the chance that we get? What is the probability of getting a first blue one? The bag is like this. What is the probability? There's 5 blue ones out of 8 in total, right? Probability of getting blue on the first draw. Now, given that this happened, that this was actually a blue marble, what are our chances now on our second draw of getting blue? We're going to multiply it by that probability. What are the chances of getting blue now? There's 4 blue ones left out of 7 marbles in total. Yeah? 4 out of 7 that we got this one. Now, we pulled it out. It's out. Now, given that those 2 blue marbles are already out, what is the probability of getting red on this third draw? Let's see. Chances of getting red. There's 3 red out of a total of 6 marbles. Yes? These 3 probabilities, all we need to do now is to multiply them together. 5 times 4 times 3 is 60. 8 times 7 times 6 is 336. Now let's simplify. I can divide both by 6. 56, yes. They're both even, so I can divide both by 2. Let's do that. And that's about as simplified as it gets. All right, so the probability of getting blue, blue, red is equal to 5 out of 22. Or I could say it more in words, probability of getting the first red marble on the third selection is equal to 5 out of 28. All right, cool. And we did this without using a probability tree. And the reason that it was fairly simple, even though these are dependent events, the reason it's fairly simple is because there's only one way of getting red for the first time on the third draw, right? If in our probability tree we are adding, like, say the question was, what are the chances of getting 1 hit in 4 attempts? Then we would have to add multiple probabilities out of the probability tree, right? And then it would be more complicated. But because there's only one way of getting the first red marble on the third attempt, that's why it's fairly easy. Okay, that was cool. See you later.